So initially when you look at these kinds of problems, you could see that you could possibly get the positive charge on the cation here on the basis of where it is on the periodic chart, because each of these are just group 1 cations, so they're going to be in group 1, group 2, or they're going to be aluminum, so the charge is predictable from the periodic chart. But again, what I want you to do is get into the habit of not looking at the periodic chart to get the positive charge on the cation, because it doesn't always work for you. There are going to be cations that you don't know the charge for. Those will be the type 2, so you're going to have to figure that out based on the charge on the negative side of the compound. So if we've got this kind of situation, we've got Na2SO3. Each of these happens to be a polyatomic ion. Now what I mean by polyatomic ion is that the anion side here consists of more than one atom. So we can see if we drew this out, it'd be Na2 and then one SO3 group. Remember the 3 here only covers the oxygen, and this entire thing is just one unit, so it'll be SO3. And there's not 3 SOs or anything like that, it's just one SO3 group. If there was more than one of these, the situation would have been similar to something like this, where we have SO43, for example, where we'd have 3 SO4s, and we'd know that because there were parentheses here and a 3 on the outside. Alright, so looking at this one, we've got Na2SO3, that's 2 NAs and 1 SO3. And what I do is I look up the SO3 charge on the polyatomic ion sheet. So I just go ahead and find it, and I see the SO3 is down here. So it's SO3 and has a -2 charge. So for any of these polyatomic ions, you'll have to use this polyatomic ion chart. You really just can't look at it and figure out what the charge is. You can't look at the elements and figure out what the charge is either. It's always going to be off the polyatomic ion sheet as I've got over here. Right, that means the total negative charge is -2 because I've only got one of these SO3 groups. Okay, so -2 charge, and it means the total charge over here is going to be +2, which means each of these has to have a +1 charge. So the name of this would be sodium. And then I just look up the name on the polyatomic ion sheet. There we go, sulfite, SULFITE. And it's, for this, just a matter of just copying the name directly off the polyatomic ion sheet. These are a little bit different to the single element ions where we had to add IDE to the end. But those were because those were single elements. They came off the periodic chart. There were situations like this. All of those end in IDE because of the fact we got them off the periodic chart. And the charges here for the other one, they all come from the polyatomic ion sheet. Alright, so that's sodium sulfite. And again, since these are group 1s, we know that sodium always has a +1 charge. So we don't need to put the charge 1 in the name, and we won't do it for any of these. Okay, so moving on to the next one. We've got CaCO3, and that's going to be 1 Ca and then 1 CO3 group. Remember, we've only got 1 CO3. If there were more than one, we'd have that in parentheses. So we look up CO3 on here and we see the charge is -2, there it is. And that means that the total negative charge is -2, the total positive charge has to be +2, which means the calcium has to be +2. So the name of this would be calcium and then carbonate, just copying the name directly off here. Again, no need for calcium 2 or anything, because calcium always has a +2 charge because it's in group 2. You can see it down here, group 2. So it's always +2. Alright, looking at the next one, we've got MgOH2. Now if I drew a picture of that, it would look like Mg. And then you see the OHs are in parentheses and there's a 2 on the outside. That tells me I've got 2 OHs. So now what I do is I go over here and I look for OH. There it is, -1 charge, -1, -1, total -2. That means that the total positive charge is +2 to match this one, and the charge on the magnesium is going to be 2+. So the name of this one, magnesium hydroxide. Again, no need to put a number or charge in the name because magnesium is in group 2, it always has a +2 charge. Alright, so looking at the next one, we've got Al2SO43. If I drew a picture of that, it would be 2 aluminums. And you see you've got SO4 with the 3 on the outside. Total -2, -2, -2. And I get that off here, we get SO4 is -2 from over here. Total charge, -6. Total positive charge, +6. Each aluminum would have to be 3+, so we match that up. And the name of this then would be aluminum sulfate. Again, we know that aluminum is in group 3, so it has a +3 charge all the time. No need to put a 3 in the name. Likewise, sulfate is always -2. Alright, so that's the name of that. Let's move on to the next one, CSBRO3. So that's 1 CS and then 1 BRO3. The charge on BRO3, we look over here, there it is, bromate, that's -1. Total negative charge, -1. Total charge on the positive side, +1, which means the CS has a +1 charge. The name of this would be cesium bromate. Again, I just get that off here for the bromate. Cesium is type 1. This is in group 1 here, so I don't put a number in the name or anything, so it just becomes cesium bromate. Again, I want to point out there's only one BRO3 group here, not more than one. If there was more than one, it would have been in parentheses. For each of these, the ions we're looking for in the answers will just be the single ions in each case, the ones I'm circling. So Mg2+, just one of the OH minuses here. In the case of the aluminum sulfate, Al3+ and SO42- are the ions. And in this case, it's these guys here. It's these single ions here that are used to get the names that we're talking about.